Okay, gentlemen, let's take a look at 2.3, day 1 of 4. And if we take a look at the review true and false questions, just to get the juices flowing here. The first question is 2, 2, and 8 are the side lengths of a right triangle. So we know that a right triangle has to be a squared plus b squared equal c squared, which is true for all right triangles. If we were to sketch it, we know that the length of the longest side, 8, has to be the hypotenuse, right? And this would have to be 2 and 2. If we follow the Pythagorean theorem, that means 2 squared plus 2 squared has to equal 8 squared. We know that's 4 plus 4 equal 64. 8 does not equal 64. So this one is definitely false, not a right triangle. The slopes of perpendicular lines multiply to -1 or have a product of -1. But this we just have to test out. If my slope is 2, right, then my perpendicular slope is -1/2, the negative reciprocal. If I were to multiply 2 times -1/2, right, that's the same thing as saying 2/1 times -1/2. I'm going to get -2/2, which is equal to -1. So that's true. Slopes of perpendicular lines do indeed multiply to -1. All right, looking at the learning goals for today, you can see here, these are just some basic good math principles. You can use analytic geometry to determine the properties of geometric shapes. That's just telling us that we can analyze lengths of lines, midpoints, using slope. We can determine different properties of shapes. We can determine the radius of a circle. We can determine, again, the length of a line, that type of thing, the shortest distance from a point to a line. And then when you're solving multi-step problems, when we're using slope, midpoint, equations of lines, all that kind of stuff, all those equations, it helps to first obviously understand the problem, then choose a strategy, because there's multiple entry points, right? What one person might do might be different from someone else because you might think differently. But we're using the same formulas, but again, you might have a different approach. So think about the problem, choose your strategy that you want to use, carry out the strategy by showing all your work, and then reflect. Did I answer the question? Did I accurately prove or determine the length of a line or the midpoint or an equation of a median, that type of thing? Sometimes a graph or a sketch can help, even something as simple as the little right triangle that I drew up above there, to try and sketch it out and use an example. That helps you. And then you can, as I said before, you can use multiple methods to solve the same problem. Okay. All right, I went ahead and pre-filled in some work here to make this video a little bit shorter. So let's take a look at the first example. The coordinates, or the first question, the coordinates of the endpoints of a diameter of a circle are 8, 6, and 2, 0. So I went ahead and drew a circle and showed that the endpoints of the diameter both fall on the circumference of that circle. It says find the length of the radius. Well, I drew the diameter. We know the radius is half the diameter. But let's go ahead and plug in what we know right now. So x2 minus x1 is going to be, for me, I do 2 minus 8 squared. And then y2 minus y1 is going to be 0 minus 6 squared. So that's going to equal 2 minus 8 is -6. So I really have -6 squared. It has to be in brackets. And then plus, again, -6 squared. So that ends up just being the square root of 36 plus 36, which is the square root of 72. Now, you might find in some of your work that they simplify the radical. If you look at the answer key at the back of the text, sometimes they simplify the radical. Well, first of all, we know that radius equal 1/2 of the diameter. So we have to cut that in half. So our answer is, therefore, root 72 is really being divided by 2. But the numerator 72 can be broken down. And the way we do that is like this. We can break that down technically into the square root of 36 twice, right? I might actually put this the other way around. We'll do 2 times square root 36 is the exact same thing as saying root 72. but that's also being divided by 2. And we know the square root of 36 is really 6. So that's technically, we can say 6 root 2 divided by 2. Well, I know that 6 divided by 2 is 3. So my answer is really 3 root 2, right? Because 6 divides by 2 evenly. So that's the final answer. That is the most, what we call simplifying the radical. Okay, the square root. We simplified that as much as possible. If you have more questions about that, we can look at some more examples. But just keep in mind that when you're looking at the answer key, you may get a simplified radical as your final answer. All right, next question. Plot the points A, B, C. And it asks us, so I did that already, obviously, and it's asking us, is triangle ABC right? Is it a right angled triangle? And prove your conclusion. If I'm looking at the triangle, because we've sketched it, it's pretty common sense that if there were a right angle, it would be right here, right? So in order for us to determine whether or not it's a right triangle, a right angle really means perpendicular slopes, right? So if that's the case, let me go ahead and calculate the slope of line AB and then the slope of line AC. And if those slopes are negative reciprocals, then we have a right angle triangle. If they're not negative reciprocals, we don't have a right angle triangle. So the slope of AB, again, using these coordinates here, y2 minus y1 is going to be 9 minus 0 over x2 minus x1, which is 4 minus 8. So that ends up being 9 over negative 4. I'm just going to write that differently. I'll write negative in the middle, negative 9/4. So that's the slope of that line. AC, now we're using these two coordinates. And we have y2 minus y1, which is negative 4 minus 0 over negative 2 minus 8. So that's negative 4 over negative 10, which can both be divided by negative 2. So that's going to be 2 over 5. Well, 2 over 5 is not the negative reciprocal of negative 9/4. So therefore, triangle ABC is not right because AB is not perpendicular. That's our symbol for perpendicular, is not perpendicular to line AC. Okay, there we go. Determine the shortest distance from the point 4, 4 to the line x plus y equals 0. I went ahead and took that equation and I converted it to y equal mx plus b format. But you notice there is no plus b there. The reason why there's no plus b is because it's direct variation. It does not have a y-intercept. It actually passes through the point 0, 0. Y equal negative x tells us the slope is negative 1. And if the slope is negative 1, first of all, it's negative, so it's sloping down when we read it left to right. And it happens to have no y-intercept, so I know it passes through 0, 0. Whatever x is, y is the negative of that. So when x is positive 1, y is negative 1. When x is 2, y is negative 2. When x is 3, y is negative 3. And that pattern just continues, right? And same thing with the other direction. When x is negative 1, y is positive 1. When x is negative 2, y is positive 2. So it's just basically the opposite of the x values, or negative version of the x values. But the shortest distance from the point to a line, we're going to learn this as we get through 2.3, is basically a perpendicular line or a right angle. The shortest distance from 4, 4 to that line would be a right angle. And that kind of makes sense, right? If I drew that line this way, that's definitely a longer line. It looks more like a hypotenuse, doesn't it? So the shortest distance, right, again, if I went this way, that's a longer line than the dotted line. The shortest distance from any coordinate to a line is a right angle. Okay, and that's that. Thanks, gentlemen. Hope that makes sense. Good luck with the homework. We'll talk to you soon.